In this lesson, we are building our understanding of one of the types of rocks known as sedimentary rocks. Sedimentary rocks are one of the three basic types of rocks, with the other two being igneous and metamorphic. However, of the three types, only sedimentary are capable of containing fossils. Why? Well, you'll have to watch the video till the end to find out. However, I can give you a bit of a hint, and that is that all rock types are classified by the way they form. In the case of sedimentary rocks, we see that they mainly form from sediments that get compacted or cemented together. Sediments can be defined as fragments of organic or inorganic material that have been broken down. So if you're holding a sedimentary rock in your hand, that rock might actually contain little weathered pieces of pre-existing rocks, or it could have fragments of shells or minerals, or even the remains of plants and animals. These fragments settle in areas on the Earth's surface or at the bottom of a body of water and get squeezed or glued together over time, forming strata, or layers of sediment. The formation of strata, along with the ability to preserve fossils, are two distinct features of sedimentary rocks. There are three types of sediment and therefore sedimentary rocks: clastic, biogenic, and chemical. And we differentiate the three based on the fragments that come together to form them. Let's take a look at the first type mentioned, which was clastic. Clastic sediments are composed of fragments of rock. In fact, a clast is the word we use to describe a rock fragment, so this term is fairly easy to remember if you recall that fact. These fragments are chipped away or weathered from pre-existing rocks due to natural forces that act on them, such as water, ice, and wind. Due to this constant eroding or rubbing away at the pre-existing rocks, we sometimes see clastic sediments going by the name of detrital, which means to rub away. So whether you are using the word clastic or detrital, you can remember that this type of sediment is made up of rock fragments that have been rubbed away from existing rock. We classify clastic sediments based on the dominant grain size. So you could have a clastic sediment where the predominant clast size is a boulder. This would mean that the fragment has a diameter that is bigger than 25.6 centimeters, which is about the size of a basketball. The fragments then go down in size, with the next largest being a cobble, followed by a pebble, sand, silt, and finally the smallest grain, which is clay, which if you held in your hand would feel very fine, like you had a handful of flour. Now you just learned that clastic sediments are formed from inorganic fragments chipped away from rock, and this is something that differentiates them from the second type of sediment known as biogenic. You know that the prefix bio means life, so you probably have an inkling that this type of sediment contains some organic material. And in fact, biogenic sediments are created from the life activities of organisms. For example, some marine organisms have the ability to grow shells. Eventually, those organisms will die, and biogenic sediments will be composed of their shell remains. We might also expect to see some skeletal remains from other marine organisms or fragments of other living things, such as coral reefs, found in this type of sediment. Limestone is an example of a sedimentary rock that is composed mainly of calcium carbonate from the skeletal fragments of marine organisms. Another sedimentary rock that comes from biogenic sediment is coal. Coal forms when plant and animal remains accumulate and get compressed and converted to solid carbon. Of course, this is a slow process taking millions of years, which is why coal is considered a non-renewable energy source. The last type of sediment for us to consider is chemical. Chemical sediments are different because they are not made up of fragments that get weathered or broken down, but instead they are composed of mineral crystals that form out of solution. Let's take a look at how this works. We know that water can have dissolved elements in it. For example, seawater has salt dissolved in it. If water becomes oversaturated with dissolved elements, which can happen when some of the water evaporates, those elements may no longer be able to remain dissolved. The result is that solid mineral crystals separate out of the solution in a process known as precipitating. Rock salt, or halite, is an example of a mineral found in rocks that forms from the evaporation of water. Rock salt forms from seawater, which is salty. When the water evaporates, the salt is left behind in the crystal form that we call rock salt. So rock salt is an evaporite, which means that it is a mineral deposit left behind after water evaporates. Now for the answer to the question you have been waiting for. Why are sedimentary rocks the only type of rock that can contain fossils? Well, we learned that sedimentary rocks form anywhere sediment collects and piles up. Because of this fact, sedimentary rocks have the unique ability to preserve a record of the organisms that existed when they formed. With the formation of igneous and metamorphic rocks, however, we see that there is a need for a lot of heat and/or pressure. This heat and pressure destroys fossils. So if you see a rock and it has a fossil imprinted on it, then you know for sure that it is a sedimentary rock. Let's review. Sediments can be defined as fragments of organic or inorganic material that have been broken down. These fragments settle in areas and form strata, or layers of sediment. The formation of strata, along with the ability to preserve fossils, are two features of sedimentary rocks. There are three types of sediment, and therefore sedimentary rocks. One type is called clastic or detrital, and is composed of fragments of rocks or clasts. We classify clastic sediments based on the dominant grain size. From the largest to smallest, we see a boulder, a cobble, a pebble, followed by sand, silt, and clay. Another type of sediment is called biogenic, which is created from the life activities of organisms. For example, in biogenic sediment, we might find fragments of shells or coral reefs or skeletal remains of marine organisms and end up with a sedimentary rock such as limestone. Or you could have the accumulation of plant and animal remains that get compressed to form coal. The last type of sediment we considered was chemical. Chemical sediments are composed of mineral crystals that form out of solution. This happens through precipitating, which is the process by which solid mineral crystals separate out of the solution. Rock salt is an evaporite, which means that it is a mineral deposit left behind after water evaporates.